Welcome to today's video. In this video, we are going to solve one more lead code question, and the question number is 234 palindrome linked list. It's come under easy, but it has been asked in many good companies like Google. Why it is different? Why it comes under easy, but at the same time, it is very difficult to solve because company adds a lot of constraint over here. So we'll go through that one by one. What are the constraints and how to solve this question stepwise? So let's get started. So the first thing we need to understand this question. So here the question is saying you have been given a head of the singly linked list, and we need to return a boolean whether it is true or false depending if it's a palindrome or not. So if it's a palindrome, we need to return true, and if it is not, then we need to return false. So the first thing we need to understand over here, what is the palindrome? So if you have never heard of this term, the palindrome is any number or a string which can be reversed and still spell it in the same way, like 1 to 1 or 1 to 1, like the example. Or if you read it from the front or from the back, it is the same. Another example will be ABA or ABBA. So it does not matter if it is a even number or even size or a odd size. Okay, so that is called a palindrome. Okay, so we need to solve this. So first thing what we will do, we will how we can solve this. So we need to traverse somehow from the front and in the back, right, of this linked list. So the one way to solve is using the stack. That is a very quick thing that comes to your mind. It should come to your mind for resolving this. So we are going to create a stack. Okay, stack of integer value. Okay, let's name it sc and create an object of it. Okay, so now what we are going to do, we are going to take a variable called current, and we are going to initialize it with our head of the linked list. Now we will traverse through this list current. So we'll traverse through this list via current, and we are going to push that data, push the value into the stack. Okay, dot val, and we are going to move the pointer to the next linked list, to the next node. Oh, sorry. Okay, so at this point of time, what we are going to do, so we are going to add these numbers in the stack. So we are going to add first 1, then 2, then 2, then 1. Okay, so now in our stack it is somewhat like this. 1, so I'll just show you like this. 1, then on top of it 2, then on top of it 2, and then on top of it 1. So this is our stacks looks like after this piece of code. Okay, now we are going to reinitialize the current variable with the head. Okay, so we are kind of reusing the same variable. Now we are going to iterate once again in the while loop, where we are going to check our current is not equal to null, and current dot val is equal to stack dot pop. So what we are going to do, again we shifted our, so if this is our list 1, 2, 2 and 1, so again our current is over here, and now this is our stack. So what we are going to do, we are going to traverse like this with this current variable, and we are going to pop the stack. So we are not going to check whether the stack is empty, because the number of the elements in this list and in this stack will always be the same. Okay, so what we are going to check, we are going to check if our current dot value which we are popping from the last, because it is last in first out, right? So this will be at the top. So if this, and if you are navigating from the front, if both are equal, then then it's a palindrome, right? So if that's the case, we are going to move the cursor to next node. Okay, now we are going to return current if it is equal to null. So if it is equal to null, it means it reached to the end and it is a palindrome. Okay, and if not, it will return false. Okay, so let's try to submit this. 1 minute. Okay, sorry, variable name is st. Okay, so we submitted this using the stack. Now the second thing, so now can we do this without using the stack? That is the thing. Yes, we can. So now currently what we are doing, so we are taking an explicit space, that is stack, and then we are doing it. What if we can take an internal stack? And what is an internal stack? Like if we use the recursion, we can take the stack where the function calls sets, right? So in that case, what we are going to do, we are going to use the recursion. But for using the recursion, we need to have a class level variable. Okay, we are going to create a list node called head. Okay, now what we are going to do, let's reset this first. So for doing the recursion, for solving this via recursion, what we are going to do, we are going to take a private variable called head. Now inside this, we are going to initialize the head with the, let's rename this as root. Okay, so we're going to initialize it as root, and now we are going to create one more variable called current, and we are going to initialize it also with the root. Root is nothing but the head, but I just renamed it, okay, because we are going to use this name as the head. Now we are going to take a helper method which will return us the actual result. We'll name it as check palindrome, and we are going to pass our current node. Now let's write our helper method. So it will be private. It will also return me boolean, and the name is check palindrome, and it is going to have the parameter as current. Okay, now we need to use the recursion in the way that it will act as a stack. Okay, so why I showed you beforehand the implementation using stack, so that you will be able to understand the recursion more easily. Okay, so we are going to do, if our current is null, so if it is no element, we are going to consider it as true. Okay, now if my check palindrome for the next element is not true, or my current value is not equal to head dot value, then we are going to return false. So let's understand this. So what we are doing here, so for the first time you come here, so currently if my list is 1 2 2 1, okay, so you come here, now you are accessing current, okay, and now your head is also here, right? So both the things are pointing to this. Now let's write it. So our head is also here, and currently our current is also here. Okay, now you are seeing that current is not null. Obviously we are pointing to 1. So you come here and you are calling again the check palindrome, and what it is calling, current dot next. So again you are moving to this method, and the second current dot next is called. So what is the current dot next is 2. So our current comes over here now. Now again the same thing, current is not null, then it goes to next, then our current came here, now again dot next, now our current came here, right? So now our current came here, and after that if current goes to here, now this current will be null and it returns me true. Okay, so if it returns me true, this became false. Okay, so false case we'll not consider right now. So let's first check if I'm returning from here. So if I'm returning from the last element, okay, so if I come over here, if I'm returning from the last element, then my current dot val is 1 because I'm at the last right now. Okay, now and head dot val, so my head is still at the 1. So these two are getting compared and both are 1. And that is the thing we have to do for checking for the palindrome, right? So we need to check the first and the last element, and then we need to move the first cursor to the right and the right cursor to the left, and we need to equalize it, right? We need to do the equality check. So this will be null. Now again, if this is false in some way, like if the value is not true, then we are going to simply going to return false, right? Else means if both are equal or check palindrome is true. If it is returning true, then in that case what we need to do, we need to move the head also. Now 1 and 1 is equal. Okay, so we need to move the head also, right? So because this will act on it itself because of the recursion. So once the recursion will get resolved, it will keep on moving back. So this also this head also needs to move forward, right? So we are going to move the head to head dot next. Okay, and now we need to return true. This is it. So now we are going to check palindrome. If palindrome returns true, then this becomes false, right? And we are going to move the head. If any of these two things return false, then in that case we are going to return the false. Okay, so here we are taking the help of internal stack using recursion, but we are doing the same thing. Let's try to submit this. Okay, so the performance is much better. So earlier it was 14, now it became 8 ms, right? Now again, now if interviewer comes to you and says like, can we do that without using any extra space? That's what make it a bit more difficult, and you need to think more, right? So if you see the description, it's an easy question, but when we add the constraint on top of it, it becomes a little hard. Okay, so let's try to think. So what we can do now, so how we test for the palindrome, that we need to think. So we do that when we need to check half of the string, like if both are equal. So what we can do, we are going to reverse half of the string, and then from half we are going to check for equality. So what I'm suggesting over here, so suppose my list is right now 1 1 2 1. So what I am suggesting, to reverse half of the list. So let's reverse first half of the list, okay, or second half, any one is fine. So let's reverse first half. So what we are going to do, we are going to make it to 1. So this got reversed and rest half remains the same. Okay, so now what we are going to do, we are going to compare from the first and from half of the list. So this becomes half of the list, so we are going to start comparing from here and here. So if both are equal till end of the list, then it's a palindrome. Okay, so let's use this concept. In this concept we are not going to use any extra space. So let's see how. Okay, now for this we need to reverse the linked list. So we need to have a functionality called reverse as a helper method. So I'm creating a private method which will return me the list node. Okay, and it will reverse the linked list. Okay, so let's add the head. So for this we are going to create two variables, previous, which will be null, and the current, which is the head. Okay, so we are going to traverse. Okay, if current not equal to null. Okay, so we are going to first save our next in some variable. Now we need to update current dot next with the previous. Now our previous became current and our current becomes next. So this will reverse our linked list. Okay, and we are going to return the pref. Okay, so let's add in this functionality now. So here what we are going to do, so to get to half of the node we are going to use fast and slow pointers. Okay, slow, so we are going to initialize it with the head, and a fast pointer we are going to initialize it with head head dot next. Okay, so now we are going to traverse it. So if our fast not equal to null, and my fast dot next also not equal to null, then slow will move one at a regular pace, like one after another, slow dot next, and my fast will move much faster. This is fast dot next. Okay, so by the time fast reaches to the end, slow will come at the midpoint. Okay, since now we got the midpoint, so we are going to reverse our linked list, but we don't have to reverse the full, right? So we are going to reverse our from slow dot next. So second half of the list we are going to reverse. Okay, now we reversed it. Now we are going to do slow dot next equal to null. So now again we will start comparing. If our reverse is not equal to null, okay, why we are only using reverse? Because it will only reach this is the second half, so it will reach to the null. Okay, if we are comparing from the first half will come later, right? So this will reach to the end much faster than the first pointer. So now what we are going to do, we are going to compare with the head, because head is over here and our reverse is over here, rev. So if our at any point of time head dot val is not equal to reverse dot val, then we are simply return false. Okay, else we are going to do head equal to head dot next and rev equal to rev dot next, and if it passed, then we are going to simply return the true. Okay, so let's try to submit this now. What is okay? Sorry, I've added the space. Okay. Yes, now it is see 4 ms. So hope you understood this question, and if you have any comments, please feel free to share. See you in the next. Thank you.